Hello children, how are you all? Very good. I have seen your homework that you have completed. Very good. Some children are missing. Okay, do fast and submit it. Okay. Now we are going to into the second part. Okay. In previous classes we have seen about what is chemistry and how the chemistry plays in our life. Okay. And the classification of matter, physical classification, chemical classification, what is element, what is a compound, homogeneous, heterogeneous, isn't it? And atomic masses, molar mass, molecular mass, mole concept, Avogadro number, molar mass, molar volume. Okay, these all the things we have studied in our previous class. Do you understood, children? Okay, now we are going into the next part. Okay, the unit 1 is basic concept of chemistry and chemical calculations. Now what is gram equivalent mass? Gram equivalent mass. Okay, it is similar to the mole concept. It is similar to mole concept. The gram equivalent concept is also widely used in chemistry, especially in analytical chemistry. Okay, especially in analytical chemistry. In the previous section, we have understood that mole concept is based on molecular mass. Okay, in the previous section, we have understood that mole concept is based on molecular mass. Similarly, the gram equivalent concept is based on equivalent mass. Similarly, gram equivalent concept is based on equivalent mass. Okay. See the definition. What is gram equivalent mass? Gram equivalent mass is defined as the mass of an element that combines or displaces 1.008 gram hydrogen or 8 gram oxygen or 35.5 gram chlorine. Okay. For example, in a reaction zinc plus H2SO4, what happens? It is displaced to ZnSO4 plus H2. So, in this reaction 1 mole of zinc displaces 1 mole of hydrogen. Okay, 1 mole of zinc is displaced by 1 mole of hydrogen. Do you understood? What is gram equivalent mass? It is defined as a mass of an element that combines or displaces hydrogen or displaces oxygen or displaces chlorine. Okay, hydrogen is displaced by zinc, zinc is displaced by hydrogen, oxygen is displaced by zinc, zinc is displaced by oxygen, like that. So, it is defined as a mass of an element that combine or displaces the hydrogen. Do we understood, children? This is gram equivalent mass. Okay, the gram equivalent mass has no unit. Okay, gram equivalent mass has no unit, but the gram equivalent mass has the unit gram equivalent minus 1, gram equivalent minus 1. So, that is gram per equivalent. Okay. It is not always possible to apply the definition based on 3 references, namely hydrogen, oxygen, chlorine. It does not based on these 3 references. Only hydrogen, oxygen, chlorine மட்டும் replace பண்ணனும்னு சொல்ல முடியாது, but we cannot conceive of reactions involving only with those 3 references. We cannot conceive a reaction. Okay, we cannot conceive or we cannot create the reactions involving only with these 3 references. Therefore, more useful expression used to calculate gram equivalent mass is gram equivalent mass is equal to molar mass by equivalence factor. Molar mass by equivalence factor. Molar mass by equivalence factor. What is gram equivalent mass? Gram equivalent mass is defined as a mass of an element that combines or displaces hydrogen, oxygen, chlorine in a specific grams. Okay, gram equivalent mass is equal to molar mass by equivalence factor. Do we understood, children? See here, equivalent mass of salt, okay, equivalent mass of salt. The salt is NaCl, MgCl, okay, sodium chloride, magnesium chloride, okay. The formula, equivalent mass of salt equal to molecular mass by total number of positive or negative charge, okay. See here, in NaCl it is classified as Na plus Cl minus, Na plus Cl minus. See here, molecular mass of sodium chloride, okay, 23 plus 35.5 and divided by the positive or negative charge number, okay, that is plus minus. So, it is 1. So, the answer is 58.5. In MgCl2, it is classified as Mg plus plus 2Cl minus, okay, 2Cl minus, okay. Now, see here the molecular mass of Mg, and Mg is 240 plus the molecular mass of chlorine is 2, because chlorine is 2 molecules. So, 2 into 35.5 divided by 2. 2 is the positive charge, okay, Mg plus plus, okay, right. The answer is 47.5. This is the method of calculating equivalent mass. Now, see here, equivalent mass of acids, bases, salts, oxidizing agents and reducing agents, okay, given here. See first acids, okay. First acids, equivalent factor is N, equivalent factor N, that is basicity. What is basicity? Basicity is number of moles of ionizable H plus ions present in 1 mole of a acid. Number of moles of ionizable H plus ions present in 1 mole of acid. 1 mole of acid la irukkudiya H plus ions. Number of moles of ionizable H plus ions is basicity. So, the formula for calculating equivalent mass E equal to molar mass of the acid divided by basicity of the acid. Molar mass of the acid by basicity of acid. Equivalent mass E equal to molar mass of acid by basicity of acid. For bases, molar mass of base by acidity of base, okay. Now, see the first example, H2SO4, that is a basicity, okay, equal to the basicity of H2SO4 is hydrogen sulfide, basicity is 2 equivalent mole inverse, 2 equivalent mole inverse, okay, because hydrogen having 2 atoms. So, H2, so 2 equivalent mole, okay. Do you understood, children? And the basicity value is 2, okay, that is N value, that is N value. Now, molar mass of H2SO4, now going to calculate the molar mass, okay. Now, H is sorry, there are 2 hydrogen molecule H2 and the atomic mass of hydrogen is 1, okay. Atomic mass you can see in periodic table, okay. Now, you take your periodic table and see hydrogen atomic mass is 1.008 or 7 is given. So, we are taking as a rounded value 1, okay. So, 2 molecules of hydrogen, so 2 into 1, then adding plus S, H2SO4, H is completed, S is only 1 S value. So, 1 into 32, 32 is the atomic mass of sulfur, okay, and plus oxygen is 4 molecules. So, 4 into atomic mass of oxygen 16. So, now multiply it and add it, it gives 98 gram mole inverse. Now, divided by 2, the 2 is the basicity, 2 is the basicity of H2SO4, 2 equivalent mole inverse, no. So, divide it by 2, now the answer is 49 gram equivalent inverse. In second basis, KOH acidity is taken, KOH, okay. That is hydrogen value is 1, hydrogen value is 1. So, 1 equivalent mole inverse. The molar mass of KOH, okay, potassium hydroxide, Okay. So, first K value, okay. See the atomic mass of K, that is 39, and it is only one molecule. So, 1 into 39 plus oxygen, 1 molecule of oxygen, and the atomic mass is 16 into 16 plus hydrogen, it is a 1 and atomic mass is also 1. Now, the answer is multiply it, add it, 56 gram mole inverse 1. Okay. Take the note and write. Okay. Then only you can understand it. Now, divided by the acidity, that is 1. So, answer is 56 gram equivalent minus 1. Next, you are taking oxidizing agent or reducing agent. Okay. Oxidizing agent. We can see about oxidizing agent in this lesson afterwards. Okay. Now, what is N? Okay, number of moles of electrons gained or lost by one of the mole of the reagent during redox reaction. So, E equal to molar mass of the oxidizing or reducing agent by number of moles of electrons gained by 1 mole of oxidizing or reducing agent. This is the formula. We are taking an oxidizing agent KMNO4, KMNO4, potassium dichromate. Okay. Right. Molar mass of that KMNO4 is K 1 into 39, for M 1 into 55, for Mn, okay, that is manganese. Okay. So, 1 into 55, then oxygen 4, 4 into 16. Okay. Then multiply it and add it, 158 gram mole inverse. Do you understood? Now, the N value is 5 equivalent. How it came? It came by the equation C. MnO4 plus 8 hydrogen plus 5 electron gives Mn2 plus 4 H2O. Okay. So, N value equal to 5. So, divide by 5, the value is 31.6. Okay. These are the equivalent mass of acids, bases, salts and oxidizing reducing agents. Okay. Do we understood, children? Mole concept requires a balanced chemical reaction to find out the amount of reactions involved in chemical reaction, but gram equivalent concept does not require the same. We prefer to use mole concept for non-redox reactions and gram equivalent concept for redox reaction. Okay. For example, if you know the equivalent mass of KMNO4 and anhydrous ferrous sulfide, without writing balanced chemical reaction, we can straightway say that 31.6 gram of KMNO4 reacts with 152 gram of FeSO4. Okay. The same concept is explained in mole concept. Okay. Now, let us see what is empirical formula and molecular formula. What is empirical formula? Okay, basically an empirical formula represents the simplest whole number ratio of various atoms present in a compound, whereas molecular formula shows the exact number of different types of atoms present in a compound. Okay. There is a steps for calculating the molecular formula. Okay. I will tell you later. First of all, elemental analysis of a compound gives mass percentage of atoms present in the compound. Okay. Using the mass percentage, we can determine the empirical formula. Molecular formula of a compound can be arrived from the empirical formula. Okay. Molecular formula la irundhu empirical formula va derive பண்ணலாம். Empirical formula la irundhu molecular formula va derive பண்ணலாம். Okay. Right. Empirical formula of a compound is a formula written with the simplest ratio. Written with the simplest ratio. Okay. Empirical formula written in simplest ratio of number of different atoms present in one molecule of a compound. Molecular formula of a compound is a formula written with the actual number. Molecular formula is actual one, empirical formula is smaller one and is a simpler one. Okay. Okay, I will give you an example. Okay. The molecular formula of acetic acid. Okay. What is the molecular formula of acetic acid? C2H4O2. C2H4O2. Now, the ratio is 1:2:1, and the empirical formula is CH2. Empirical formula is CH2O. Okay. Molecular formula is C2H4O2. C 2 இருக்கு, H 4 இருக்கு, O 2 இருக்கு. But empirical formula is C1H2 and O1. It is divided by 2. Okay. It is divided by 2 and it is given in a simplest way. That is the empirical formula. Okay. So, we can calculate the empirical formula. Okay, we can calculate molecular formula by empirical formula. First, we have to draw 5 columns including element, percentage composition, atomic mass, number of moles and simplest ratio. Okay, we have to draw 5 tabular columns. First of all, element, percentage, molar mass, relative number of moles, simplest ratio. After that, we will get the empirical formula. Okay, calculate it and divide it by the molar mass given, we will get the molecular formula. Okay. Now, let us see what is the difference between empirical formula and molecular formula. Okay. What is the definition for empirical formula? Empirical formula is the simplest form of formula that we can write for a molecule. It is a simplest form of formula. Simplest form. Empirical formula is a simplest form of formula we can write for a molecule. What is molecular formula? Molecular formula is the formula that showing the type of atoms and number of each atom connected in the molecule. Okay. Then what the theory says? It gives the simplest ratio. Empirical formula gives the simplest ratio of atoms in a molecule. Molecular formula gives the exact number of atom. Exact number of atom. Okay. Next, molecular mass. Empirical formula cannot get the exact molecular mass. Okay. In empirical formula, we cannot get the exact molecular mass, but in molecular formulas, we can get the exact molecular mass. Okay. We can predict the type of atoms in ionic compounds and repeating unit in a polymer. Okay. But in molecular formula, we can predict oxidation, number of atoms, their reactions and end product of reactions. Okay. Where it is used? It is used for simple molecules, crystalline ionic compounds, polymers, etc. And molecular formulas are used for covalent compounds. Covalent compounds. Okay. Now, see, there are determination of empirical formula. Okay. Steps to determine empirical formula. Okay. First of all, what you have to do? Okay. Since the composition is expressed in percentage, we can consider the total mass of the compound as 100 gram. Okay. Assume 100 gram. And the percentage values of an individual elements as mass in grams. Okay. If the given percentage composition, okay, if the percentage composition is given, then you assume 100 gram. Okay. You assume it as 100 gram sample and then convert it to percentage. Then convert the percentage to gram. Convert the percentage to gram. That is the first step. Then what is the second step? Divide the mass of each element by its atomic mass. Okay. Divide the mass of each element by its atomic mass. This gives the relative number of moles of various elements. Okay. Use the atomic masses to convert the grams to moles. Next, third step, divide the value of relative number of moles obtained in the step 2 by the smallest number of them to get into simplest ratio. Okay. Divide the moles of each element by the smallest mole fraction. Then what is the fourth step? It is only necessary, if needed, we have to do the results from step 3 should be a whole number. If it is not a whole number, they may be converted into whole number by multiplying with a suitable smallest number. Okay. Suitable smallest number. Now see here is an example. Okay. Here is an example. An acid found in a tamarind on analysis shows the following percentage composition: 32% of carbon, 4% of hydrogen, 64% of oxygen. Now, you have to find empirical formula. So, write the element is carbon, and next element hydrogen, next element oxygen. Okay, the percentage is written as 32, 4 and 64. Okay, carbon 32, hydrogen 4, oxygen 64. Okay, it is in the percentage, but you have written in the form of gram. Okay, now you are writing the molar mass. Okay, molar mass, okay, of carbon is 12, hydrogen is 1, oxygen is 16, right. Now, divide relative number of moles, calculate relative number of moles by dividing 32 by 12, 4 by 1, 64 by 16. Okay, now the answer comes 2.6644. Now, you have to give simplest ratio. Okay, now divide 2.66 by itself and 2.66 by 4 and 4 by 2.66. Okay, have you got? Now, here comes the answer. Okay, one is written as, see here, 2, 3 and 3. Okay, into 2. Okay, 1 into 2, 2, 1.5 into 2, 3, 1.5 into 2, 3. Okay, so the answer is, the empirical formula is C2H3O3. Element C, answer 2, H3O3. So, the empirical formula you have to write is C2H3O3. C2H3O3. Okay, have you understood? Now, see another example. Okay. Okay. An organic compound present in vinegar has 40% carbon, 6.6% hydrogen, 53.4% oxygen. Okay. Now, element C, HO, the percentage is taken as gram, 40, 6.6, 53.4. Now, atomic mass of carbon is 12, atomic mass of hydrogen is 1, atomic mass of oxygen is 16. The relative number of moles, 40 by 12 equal to 3.3, and 6.6 divided by 1, 6.6, 53.4 divided by 16, 3.3. Okay. Now, you are doing simplest ratio. Okay. The answer comes 1, 2, 2. Okay. Now, the empirical formula is CH2O. CH2O. Okay. This is. Now, next, calculate molecular formula from empirical formula. Calculate molecular formula from empirical formula. How you can calculate? Okay. First of all, what is a molecular formula? Molecular formula of a compound is a whole number multiple of empirical formula. Molecular formula of a compound is a whole number multiple of the empirical formula. The whole number can be calculated from the molar mass of the compound using expression N equal to molar mass of compound by calculated empirical formula. Molar mass by calculated empirical formula. Okay, right, that is the formula. Now, see here. First one, the compound acetic acid. The empirical formula of acetic acid is CH2O. Okay, this is the empirical formula, that's all. Now, the molar mass of acetic acid is 60. The empirical formula mass is 30. Now, divided 60 by 30. The answer is 2. Then, you have to multiply empirical formula with 2. CH2O into 2. Then, C2H4O2. That is the molecular formula. Okay. For hydrogen peroxide, empirical formula is HO. The molar mass is 34. Empirical formula mass is 17 divided by then 2, then multiply HO with 2, then you will get H2O2. That is the molecular formula. And for lactic acid also, tartaric acid, benzene is given. Okay. Okay. Have you understood? 2 organic compounds, one present in vinegar, another one present in solar mass, another present in sour milk, which is having the composition carbon 40, hydrogen 6.6, oxygen 53. Okay. What will be the molecular formula? You calculate it. Okay. That is your homework. Okay. Write down two organic compounds, vinegar and milk, sour milk. Right? Written, the molar mass of vinegar is 60, molar mass of milk is 90. Okay? The percentage composition: carbon 40%, hydrogen 6.6%, oxygen 53.4%. Okay? Written. Now you derive the molecular formula. Okay? Now, what is stoichiometry? Okay, what is stoichiometry? Have you ever noticed the preparation of kesari at your home? Have you prepared kesari in your home? In one of the popular methods for the preparation of kesari, the required ingredients to prepare 6 cup of kesari, okay, I will tell you about it. First of all, what is stoichiometry? The definition of stoichiometry is a mathematical way of finding the amount of chemical elements. Okay. Stoichiometry is also sometimes described as a section of chemistry. It is a section of chemistry. Okay. What are the things needed to make kesari? Rava 1 cup, 1 cup of rava, 2 cups of sugar, half cup ghee, okay, half cup ghee and half cup nuts, okay. Today you prepare in your home, okay, right. See here, 1 cup of rava plus 2 cup of sugar, half cup ghee and 1/4 cup nuts and dry fruits, okay. What will we get? We will get 6 cups of kesari. Isn't it? How it is possible? From the above information, we will able to calculate the amount of ingredients, okay. 1 cup of rava, okay, by 6 cups of kesari into 3 cups of kesari, what gives? Half cup rava. So, alternatively, we will calculate, then we will get 6 cups of kesari. So, similarly, we can calculate this required quantity of other ingredients too. So, we can extend this concept to perform stoichiometric calculation. Okay. 1 cup of rava, 2 cup of sugar, half cup kesari, 1/4 cup nuts is equal to 6 cups of kesari. Like that, in chemistry, we are balancing the chemical equation. Okay. For example, Zn plus H2SO4 gives ZnSO4 plus H2. So, 2Zn, okay. If we place 2Zn, then we will get Zn2SO4, like that. So, balancing happens, okay. So, this concept is used for performing stoichiometric calculation. In Greek, stoichio means element and metron means measurement, okay. Element measurement. So, stoichiometry gives the numerical relationship between chemical quantities in a balanced chemical equation. Stoichiometry gives the numerical relationship between chemical quantities in a balanced chemical equation. If there is a chemical equation, we should balance it, okay. The left hand side should be equal to the right hand side. That is the principle of stoichiometry. By applying the concept of stoichiometry, we can calculate the number of reactants required to prepare a specific amount, the reactants and the products having equal number of n value, okay. The values, the quantity should be equal in reactants and products, okay. For example, C plus O2 then gives CO2. So, this is 1 mole of carbon. If 1 mole of carbon reacts with 1 mole of oxygen molecule, what happens? It will form 1 mole of carbon dioxide. 1 mole of carbon plus 1 mole of oxygen gives 1 mole of carbon dioxide. Okay, there is a symbol. Okay, equal to symbol in 3 dash, okay, that is the stoichiometry equal symbol, okay, see in your book. Now stoichiometric calculations, okay, stoichiometric calculations. Stoichiometry is the quantitative relationship between reactants and products. Stoichiometry is a quantitative relationship between reactants and products. It is based on a chemical equation in moles, okay. The quantity of reactants and products can be expressed in terms of mass unit, moles or volume. So these three units are convertible. See in the picture, mass, if mass m, small m, that is mass, if mass is divided by molar mass, we can get number of moles n. If number of mole n is multiplied by 22.4 liter, then we will get the volume, okay. If volume is divided by 22.4 liter, we will get the number of mole. If number of mole is number of mole is multiplied by molar mass, then we will get the mass, okay. Okay, have you understood? Mass is divided by molar mass. In the picture itself you can understand. Mass is divided by molar mass, we can get number of moles. Number of moles is multiplied by 22.4 liters, then we will get the volume. Volume is divided by 22.4 liters, then we will get number. And n is multiplied by molar mass, we get mass, okay. This is the stoichiometric calculation, okay. To do stoichiometric calculation, this formula is used, okay, this explanation is used. So this method is used for deriving the sums, okay. Now see here, I will explain you, okay. Take your book, page number 14, okay. Right, CH4, it is in a gaseous form, plus 2O2 oxygen, it is also in gaseous form, gives CO2 gaseous form plus 2H2O gaseous form, okay. Now the reactants and products, okay. CH4O2 is a reactant, CO2 H2O is a product, okay. Now stoichiometric coefficient, stoichiometric coefficient is 1 and oxygen is 2. Again products 1, 2, that is a coefficient, okay. Now see the mole-mole relationship, okay, mole-mole relationships, okay. See in the reactant CH4 plus 2O2, there is a CH4, there is 1 mole, so 1. In O2 there is a 2O2, so 2 mole. Product also CO2 there is only 1, so CO2. H2O there is 2, so 2 mole. Okay. Now mass relationship equal to number of mole into molar mass, number of mole. So number of mole is 1, okay. Molar mass is what? CH4, okay. CH4 எடுத்துக்கோங்க, C ல கார்பன் இருக்கு, கார்பனோட அட்டாமிக் மாஸ் வந்து 12, ஹைட்ரஜனுக்கு 1, 4 இருக்கிறதுனால 4, அப்போ 12 plus 4 16, so 16, okay. Next oxygen 2 mole into oxygenோட atomic mass 32, so 32 64 kg. Product C 1 mole is taken and carbon dioxide, so அதோட atomic mass 44 gram, so you multiply with it, the answer is 44. And for water 18 gram, the answer is 36, okay. In this way you have to find mass of reactants, so mole into molar mass, you will get the answer, okay. This is the stoichiometric calculations, okay. Have you understood, children? Now what is limiting reagent? What is limiting reagent? In earlier classes, okay, we learned that stoichiometric concept is useful in predicting the amount of product formed, isn't it? What we have learned in stoichiometry? Predicting the amount of product formed in a given chemical reaction. If the reaction is carried out with stoichiometric quantities of reactants, then all the reactants will be converted into products, okay. So, on the other hand, when a reaction is carried out using non-stoichiometric quantities of the reactants, the product yield will be determined by the reactant that is completely consumed. So, it limits the further reaction from taking place. It is called limiting reagent. The reactant used up first in the chemical reaction. When any reaction is carried out, okay, when any reaction is carried out, if the reactants are not present in the amount as they are required by a balanced chemical reaction, in such situation one reactant is in excess over the other. So, the reactant which is present in the lesser amount get consumed after some time. After that, no further reaction takes place whatever to be amount of the other reactant. Hence, the reactant which gets consumed limits the amount of product formed, okay, limits the further reaction taking place, that is called limiting agent. Other agents which are in excess are called excess agent. Okay. As per the recipe, 2 cups of sugar are needed for every cup of rava. Okay. Every cup of sugar rava, 1 cup rava means 2 cups sugar we have to put. So, consider a situation 8 cup of sugar and 3 cups of rava are available. As per the cooking recipe, we require 3 cups of rava and 6 cups of sugar to prepare 18 cups of kesari. Even though we have 2 cups of sugar left, we cannot make any more quantity of kesari as there is no rava available. Hence, rava limits the quantity of kesari in this case. So, that limiting property is called limiting agent. Okay. Do you understood? That is the limiting reagent. Okay. It limits the further reaction from taking place. Limits the reaction further taking place. Okay. As per stoichiometry, 1 mole of sulfur reacts with 3 mole of fluorine to form 1 mole of sulfur hexafluoride. Therefore, 3 moles of sulfur reacts with 9 moles of fluorine to form 3 moles of sulfur hexafluoride. In this case, all available sulfur gets consumed. Therefore, it limits the further reaction. If it is consumed, then it limits the amount of the product. Okay, that is called limiting reagent. Now, what is redox reaction? What is redox reaction? When an apple is cut, it turns into brown after some time. Have you noticed? When an apple is cut, if you are not eating and making the apple in your hand for minute or for half an hour or like that, it turns into brown color. Do you know the reason behind this color change? Do you know the reason? It is because of chemical reaction. It is because of a chemical reaction called oxidation. Okay, we come across oxidation reactions in our daily life. Burning of LPG gas, rusting of iron, thuru pidikirathu. So, oxidation of carbohydrates, lipids into CO2 and H2O to produce energy. Okay, so all oxidation reactions are accompanied by reduction reaction. Oxidation reaction is accompanied by reduction. So, such reaction are called redox. Redox, reduction also happens, oxidation also happens. RED for reduction, OX for oxidation. What is oxidation? Oxidation is the addition of oxygen. Oxidation is the addition of oxygen. Reduction is the removal of oxygen from a substance. So, which substance are oxidized and reduced in this reaction? See here. Lead oxide plus carbon gives lead plus carbon monoxide. So, oxygen is removed. What happens there? Reduction. And oxygen is added to carbon, that is oxidation. Oxygen added reaction is oxidation. So, reduction and oxidation always takes place together. So, this type of reaction is called redox reaction. So, redox equal to reduction and oxidation. Reduction and oxidation. Have you understood, children? Right. Now, it is time for your homework. Note it down. Take your note. Note it down. 10 one words from the topic. Okay. From the topic, I have taught you. Write 10 one words. Okay. From gram equivalent mass concept 1.5, page number 8. Okay. From that topic to till last one, write 10 one words. Prepare yourself and write gram equivalent mass definition. Okay. Gram equivalent mass definition with example. Table 1.5.1 also you have to write. Okay. Next, steps for deriving empirical formula. You write the 4 steps and write one example. There are 2 examples in your book. Okay. You make it. Okay. Write any one example. Okay. Next, explain stoichiometry. What is stoichiometry? Give an example in a real life example, not that Rava and Kesari. Okay. You have to give another example. You have to write another example. I will check, okay, your homeworks. Write it properly, make it as assignment. Next, what is limiting reagents and give some example for it, and write what is redox reaction and give some examples for it. Have you written 10 one words, gram equivalent mass definition and also that table 1.5.1 and steps for deriving empirical formula with the example, explain stoichiometric reactions, limiting reagents and redox reaction. Okay children, have you written? Okay, study well. Okay, write the homework and assignment. Now concentrate on your studies. Okay, thank you children.